And then now let's see this question. It says given the series, so we are given the series there. And then you may notice that this is arithmetic series because arithmetic series is identified by the common difference, because you can see that moving from one term to another we add by the same number. Moving from 1 to 2 we add by 1, and then moving from 2 to 3 we add by 1, and so forth. So this question says write down the series in sigma notation if all powers of 4 are removed from the series. So first let's understand this part. Powers of 4. A power of 4 is a number of the form 4 to the exponent n, whereby n is an integer. A power of 3 is a number of the form 3 to the exponent n, whereby n is an integer. For an example, the power of 4, we are talking about 4 to the exponent 0, 4 to the exponent 1, and so forth. So they say we must remove all the powers of 4. What you should understand is that in this series we are having the numbers that are of the power of 4, and then also that are not of the powers of 4. For an example, 1 can be written as 4 to the exponent 0. 4 to the exponent 0 is 1. But you notice that 2 is not the power of 4, and then also 3. But 4 can be written as 4 to the exponent 1. And then 5 is not the power of 4, and then 6 is not the power of 4. But it's clear that because this series continues, it means there are some of the numbers that are of the power of 4. So according to this question says we must remove all powers of 4 from this series. So first, let's identify the terms that are of the powers of 4. This is 4 to the exponent 0, 4 to the exponent 1, 4 to the exponent 2, 4 to the exponent 3, 4 to the exponent 4, 4 to the exponent 5, and then also 4 to the exponent 6. Notice that we cannot write 4 to the exponent 7. This is because 4 to the exponent 7 equal to 16,384. So this number is not within this series because our last term is 5,000. So we're only looking for those numbers that are within this series. 4 to the exponent 6 is equal to 4096, and then 4096 is within this series. So it means actually our last term for the powers of 4 is 4 to the exponent 6. But remember what I said. I said this series contains the numbers that are of the powers of 4, and then also that are not of the powers of 4. What we can do, we can find the sum of this one, and then also the sum of these powers of 4, and then from there we remove this one from this series because this one contains the powers of 4 and then also that are not the powers of 4. But remember, we are going to represent this in sigma notation. So first let's represent this series in a sigma notation. We know that to represent a series in a sigma notation, we know that this is our start, this is our first position, and then this is our last term, and then this is our Tn. So this is how we represent a series in a sigma notation. So now let's go for the first term. We say n equal to 1. It means we start counting our terms from term number 1, and then this must be our last term. It's clear that we add these terms from term number 1 and then until term 5000. So it means our last term will be 5000. And then we have to write the Tn here. So what we can do is to find our nth term. You can realize that the nth term will just be n, because this is arithmetic. Tn equal to a plus n minus 1 and then times d. So our a is 1, and then our d is also 1. So from there we have 1 plus n minus 1, because you take 1 and then multiply by this bracket. So from there 1 minus 1, and then now you're just left with n. So that is why I'm saying this is n. So now we are going to remove the powers of 4, because we included everything and then also the powers of 4. So now we have to remove the powers of 4, and then we are going to say our n, of course, will be 1. So remember, now we are on this series, the powers of 4. So we start counting from this one. So this is our term number 1. So we say n equals to 1. And then now let's see our last term. Remember that this is term number 1, term number 2, term number 3, term number 4, term number 5, term number 6, and then term number 7. So it means this must be 7. And then now we must write the Tn here. But we write the Tn for these powers of 4. You can realize that this is nothing but a geometric. Remember that a geometric is identified by the common ratio. You can notice that T2 divided by T1 equal to T3 divided by T2, and so forth. So now let's find our Tn. We know that Tn for a geometric sequence is ar to the exponent n minus 1. And then this is our term number 1. And then 4 to the exponent 0, remember, is the same as 1. And then from there, let's find the r. Remember that r equal to T2 divided by T1. And then in this case, our T2 is 4 to the exponent 1. And then our T1 is 4 to the exponent 0. So you can see that our r is nothing but 4. And from there, it means this is just going to be 1. And then our r, of course, we said is 4. And then to the exponent n minus 1. So it means our Tn is nothing but 4 to the exponent n minus 1. So we have expressed this in the form of a sigma notation. So you can see that this is a series that contains everything, including the powers of 4. And then this one contains only the powers of 4. And then from there, we want to remove them from this one because it contains everything, both the powers of 4 and then also that are not the powers of 4. So that's it for this problem.